Welcome back to the Deep Dive. We're digging into a really fascinating collection of sources today, curated for us by the Pythoness Programmer. She's a digital psychic and software engineering consultant. These materials cover roughly late September to early October 2025.
Yeah, and it's quite a mix. We've got law, software, politics, markets, all sorts of things. But there's a common thread, something we're calling the amplification effect.
Right. Explain that a bit. What's the core idea?
Well, it's how technology and AI especially isn't just making things faster, it's actually boosting the complexity and the impact of everything humans do. Our decisions, our mistakes, our good ideas.
So it makes the consequences bigger, faster.
Exactly. And that's forcing us to fundamentally rethink things like trust, how vigilant we need to be, even what we mean by professional quality. There's a real shakeup.
Okay, so that's our mission for you today. Unpacking how this amplification is playing out. We'll start with a big AI reality check, looking at how it's amplifying errors and pressure in places like law and coding.
Then we'll get into the huge shifts happening underneath it all in the actual computing infrastructure. Think trillion-dollar markets being reshaped.
And finally, we'll look at these parallel struggles for, decentralized agency, both in global politics and, on the digital platforms we all use.
Yeah. So if you want the shortcut to understanding where power and accountability are really shifting right now, beyond the usual headlines, stick around.
Absolutely. Let's jump straight into Section 1, the AI reality check. And we're starting with the legal profession, where the stakes are obviously very high.
Extremely high. And the sources show this alarming trend AI use is exploding in law, but it's bringing this major accountability crisis with it. There's this researcher, Charlatan, tracking cases worldwide, over 410 documented instances where AI just introduced errors, falsehoods, ethical problems right into court documents.
410. Wow. And that California case really crystallized it, didn't it? The $10,000 fine.
Oh, yeah. That was a big one. A lawyer submits a brief, and the appeals court finds, quote, nearly all of the legal quotations are fabricated, just made up by ChatGPT, Claude, Gemini, Grok.
The usual suspects.
Pretty much. And the key thing, the court didn't just slap the fine privately. They published the decision specifically as a warning. Like, playtime's over, folks.
That's a loud warning. 10 grand and your reputation.
Yeah.
It highlights this dual problem, right? It's not just the general purpose tools like ChatGPT that anyone can use.
No, although those are definitely part of it. Lawyers are also tripping up over the fancy industry-specific tools. Things like Westlaw, LexisNexis.
Yeah.
They've now got AI features baked in.
So the lines get blurry.
Completely blurry. You use the old school database search, you get verified cases, you use the AI-assisted research, you're asking it to synthesize, maybe predict, and suddenly you need that same vigilance you'd use with ChatGPT.
But the pressure's on to be productive, use the new tools.
Exactly. The productivity pressure is immense. Adopt the tools, get work done faster, but the professional caution, the checking, that's lagging way behind.
Which brings us to what the sources call the anatomy of excuses. This is fascinating. When lawyers get caught, the explanations are, well, creative.
Oh, there's something else. It's like a masterclass in avoiding direct personal responsibility. We saw clear patterns emerge. First up, blame the tool or blame the firm.
Right. Like that Louisiana lawyer, she didn't deny the citations were wrong, but she pointed the finger at Westlaw Precision.
Yeah, she said she used the AI assist feature, thinking it was basically the same as the verified database.
Yeah.
Her defense was kind of, hey, I trusted the brand, the AI product from this reputable vendor.
Which is understandable, maybe, but still misses the point of verification, doesn't it?
Totally. You still have to check. Then you had that Michigan firm blaming an internet outage, said it made them miss a check, and the AI slipped in wrong info in parentheses.
An act of God defense, almost. Anything but we didn't have the right process.
It's all about shifting the blame. But the most frequent one, by far, was blame the staff.
The classic delegation defense. Saw that in Florida, Arizona, Texas.
Everywhere. Lawyers saying things like, I relied on her professionalism, talking about a paralegal, or claiming the assistant used AI unbeknownst to counsel.
There was that one in Hawaii, right? Sanctioned for a fake case, misattributed quotes, and he said he hired a per diem attorney he trusted. He personally didn't use AI, but admitted he failed to ensure every citation was accurate.
That phrasing, failed to ensure, it's thin, isn't it? It feels like trying to delegate the liability for basic research, which worked okay before AI could just invent things wholesale.
But isn't this just laziness? Why is the AI part so crucial? Couldn't they have just been sloppy before?
That's a fair point. But the AI amplifies the laziness or maybe the pressure. Think about it. Faking 20 plausible-looking case citations before AI. That's hard work. Days, maybe. Lots of effort. Easy to spot the fakery. Now, an AI can generate those 20 fake citations, complete with plausible-sounding details, in seconds. It looks legitimate enough that maybe you skip the check or you feel okay handing it off. The AI lowers the perceived risk and effort of cutting corners while massively increasing the actual risk.
That speed-risk ratio.
And-
Yeah, okay, that makes sense. Then you get the really human, almost sad excuses. Blame personal circumstances.
Right. These were tough. A lawyer in New York blaming vertigo, colds, even malware for not checking citations.
And another one, same state, citing the recent death of their spouse, said their focus was shot, admitted they didn't check the clerk's AI-drafted work.
You feel for them. You really do. It's intense pressure. But at the end of the day, it's still,
Right.
well, it's still about professional diligence, isn't it?
It has to be. And then the outlier, the legal experiment.
Wild one. California lawyer deliberately uses ChatGPT's deep research mode to draft an entire antitrust petition. Calls it an experiment to test the AI.
And admits nobody spent more than 15 minutes checking if it was actually, true.
Yeah. It just shows how seductive the idea of outsourcing the core thinking work can be. Look what the AI can do.
But what about the fallout? The sources mentioned a social cost, right?
Definitely. Commentators are pointing out that blaming your staff or your health doesn't really work with your peers. It's a huge blow to the respect they get.
So the professional consequences are catching up.
It seems like it. One source suggested the AI hype in law might be self-correcting because the embarrassment and the sanctions are starting to outweigh the quick productivity wins. Plus, if you have to spend more time triple-checking everything the AI spits out, where's the gain? Especially if it builds a whole argument on one hallucinated case.
Right, you could lose more time than you saved.
Hmm.
Okay, so that's the legal side. Now let's contrast that with software developers. How are they handling AI?
It's a really interesting contrast.
Right.
The DARA report, that's a big annual survey, found like 90% of developers use AI. 80% say it boosts productivity. 59% think it improves code quality. So they're using it.
There's a but coming, I feel it.
There is. When asked how much they trust the AI's output, the answer was overwhelmingly. Somewhat. Subdued is the word they used.
So they're using it, but they don't fully trust it. Skeptical optimists.
Exactly. And the sources argue this low trust is actually a good thing. It's a professional discipline. High trust, they say, reduces your own agency, lowers personal responsibility, makes you less vigilant.
And vigilance is key for developers, especially at scale.
Absolutely critical. Think about high-volume platforms, billions of transactions. If a bug has a 1,000,000 to 1 chance of happening, that's still over 1,000 times a day it could pop up. You have to be skeptical of any code you didn't write or thoroughly vet yourself.
It's not paranoia. It's just necessary caution when the blast radius is potentially global.
Precisely. And they already have a mental model for this, the Q&A model analogy.
Meaning how they treat sites like Stack Overflow.
Yeah. Good developers don't just copy-paste answers from Stack Overflow into their production code. They look at the answer, understand the pattern, figure out why it works, and then they write their own version, tailored and tested for their specific situation.
Okay, makes sense.
And since a lot of these AI coding tools were trained on, guess what? Stack Overflow data. Why would you suddenly trust the AI's summary more than you trusted the original source you were already skeptical about?
Huh. Good point. So they treat AI code like any third-party code useful for ideas, maybe boilerplate, but needs rigorous human oversight.
Exactly. It's about keeping the human in the loop, retaining agency. The AI reduces the toil, the grunt work, but the developer remains responsible for the quality and the safety. That muted trust is what allows them to leverage the tool without, blowing things up.
Okay, that's a really clear distinction. Let's shift gears now to Section 2. Emerging tech, real impact. We're talking about the underlying infrastructure making all this AI possible.
Yeah, and the numbers are just staggering. McKinsey's bullish scenario. $7.9 trillion, trillion with a T, in data center investment needed over the next 5 years.
7.9 trillion. That's almost hard to comprehend. That's global industrial scale retooling.
It really is. And for that kind of money to flow, for this AI boom to actually sustain itself, the way we buy and sell the core resource compute power has to change radically.
That's wrong with the current system.
Well, clunky is the word the sources use. Right now, if a big AI lab needs, say, 1,000 cutting-edge GPUs for 6 months, they don't just click buy on a market.
Yeah.
You have to call up AWS or CoreWeave or something like that and negotiate a bespoke price.
So it's all backroom deals, basically. No transparency.
Pretty much. It makes it really hard for buyers to shop around effectively comparing price, time, specific chip capabilities. And it makes it tough for the providers, the data centers, to compete granularly on price because there's no open price discovery.
Okay, so what's the solution then?
The consensus is that compute needs to become a proper, publicly tradable commodity. We need a liquid market. Think spot markets, futures markets, just like what happened with crude oil back in the 80s, or electromagnetic spectrum auctions in the 90s.
Right, make it transparent, standardized, tradable, but compute seems way more complex than oil, doesn't it? Oil is oil, more or less.
Yeah.
Compute has all these variables.
Exactly. That's the challenge. Chip type, is it an NVIDIA B200 or an older H100? How much uninterrupted time do you need? Do you need specific cooling? Are you willing to accept a substitute if the price is right? It's incredibly complex.
So how do you build a market around that? Seems impossible for traditional methods.
And this is where it gets really interesting. AI kind of eats its own tail. The solution to the market complexity created by AI is more AI. The sources say this liquid market is only feasible now because of something called combinatorial auctions guided by specialized AI agents.
Okay, combinatorial auctions. Break that down. How does it work?
Right, so a normal auction, you bid on one item. A combinatorial auction lets you bid on packages of items simultaneously. For compute, you might say, I need 100 H100s for 24 hours straight near this specific fast network interconnect, but only if I can get them all together as one block.
So you can specify complex dependencies in your bid.
Exactly. But defining every possible acceptable combination manually would be insane.
Yeah.
This is where the AI agents come in, using what they call expressive bidding.
Expressive bidding, meaning?
Meaning the buyer doesn't list out all the technical specs. They state their goal in, like, high-level English. Something like, need uninterrupted time, B200s preferred for speed, but we'll take H100s if they're under $2 an hour, and the job must start Tuesday.
And the AI agent translates that request
Into a structured bid package that the combinatorial auction system understands. The system then crunches all the bids and offers and finds the optimal match, the one that satisfies the most buyers' complex needs while getting the best price for the most sellers. It maximizes the value across the whole market.
Wow, so it's using AI to manage the complexity of allocating the AI hardware.
Pretty much. And the benefits are huge. Suddenly, liquidity risk drops way down. If you bought compute time and your plans change, you could potentially resell it on the open market.
And for the data centers.
Big win for them, too. Instead of needing 5 nines reliability, 99.999% on everything, which is incredibly expensive, they can sell some capacity with, say, 99% reliability at a lower price. The market finds buyers who need cheaper, flexible, maybe last-minute compute. It lets them build bigger, faster, knowing they can sell off different grades of service, justifying those huge investments.
It's basically unlocking efficiency to fuel the acceleration.
Okay, so that's the big picture infrastructure. What about the day-to-day for developers? The Pythoness Programmer flagged this thing called the parallel coding agent workflow.
Yeah, this one sounds a bit weird at first, right? Engineers are already feeling overloaded, and now they're running multiple AI coding assistants like Claude Code, Codex CLI, Google's Jules all at the same time. Doesn't that just create more code for the human to review, which is the bottleneck anyway?
That's the counterintuitive part. But engineers are doing it because they're finding clever ways to use these parallel agents to handle the really tedious, burnout-inducing parts of the job without necessarily landing all the generated code.
Okay, so what are these patterns? How are they using them efficiently?
The sources highlight 4 main ways. First, research and proof of concepts. Need to try out a new library. Tell 3 different agents to build a quick prototype using it. Maybe even tell them to read the code of the library if it's brand new. See which approach works or fails fastest.
Like sending out probes. Okay.
Second, system explanation. This is huge for dealing with old, complex code bases, the kind that kill your soul. Use a reasoning LLM to generate notes. Where are signed cookies set in this nightmare? Or which bits of this API have 0 documentation? It helps the human get up to speed way faster.
Oh, I can see the value there. Automating the archaeology.
Totally. Third, small maintenance. Just outsourcing the annoying stuff. Got 100 warnings in your test suite because a function got deprecated. Give it to an agent to fix. Keeps the human focused on the actual new feature, reduces that cognitive load and context switching.
Right, chipping away at the noise.
And finally, the most effective one seems to be carefully specified work. This is where the engineer gets authoritarian, as one source put it.
Meaning very precise instructions.
Exactly. Give the agent crystal clear, unambiguous specs. This massively reduces the review time later because the human already defined the what's and the how. There's also this send out a scout pattern. Give the AI a really thorny task, not necessarily to use the code it writes, but just to see where it struggles, what the tricky parts are. It's for reconnaissance.
So in all these cases, the human is still firmly in charge, defining the task, setting the goals, doing the final check.
Absolutely. It relies entirely on the engineer retaining agency and vigilance, using the AI for exploration and grunt work, but the human owns the quality.
But what happens when that vigilance slips?
Well, that's when you get vibe coding. And this is where the security folks start screaming.
Vibe coding. Just grabbing AI code and plugging it in because it feels right without checking.
Pretty much plug-and-play AI code. And researchers are warning it's seriously exacerbating software supply chain risks, much like blindly trusting open-source libraries did, but maybe worse.
Worse how?
Because of what one CTO called insecurity amplification, these AIs are trained on mountains of public code from the internet. A lot of that code is old, insecure, buggy, just plain bad.
So the AI learns the bad patterns, too.
Exactly. It learns the vulnerabilities and happily reintroduces them into new code. Known bugs, sometimes decades old, just pop up again because the AI saw them somewhere.
And unlike open source, there's no easy way to track where it came from.
That's the other huge problem, lack of transparency. With open source on GitHub, you usually have pull requests, commit messages, names attached. You can trace the history, see who reviewed it. AI code, it often just appears. The LLM might give a slightly different output each time, and it doesn't leave comments explaining its choices. Auditing becomes a nightmare.
And you don't know if a human ever actually verified that specific chunk of code.
Precisely. And this leads to disproportionate impact. Big companies might have resources to mitigate this, but security experts worry that vibe coding will hit small businesses, nonprofits, vulnerable groups the hardest. People using cheap, quickly developed software that might be riddled with these AI-introduced holes.
And the speed pressure just makes it worse. That checkmark survey was eye-opening.
Yeah, a third of chief information security officers saying over 60% of their org's code was AI-generated in 2024. But only 18% even had a list of approved AI tools. That's a massive governance gap. Speed way out ahead of verification. Classic amplification effect gone wrong.
Okay, let's pivot to Section 3. We're looking at the struggle for human agency. This tension between centralized control and decentralized power, amplified by tech.
And the sources give us this incredible case study in emergent bottom-up power, the leaderless revolution in Nepal in 2025.
Right, this was huge. Triggered by government crackdowns on social media, plus deep corruption, it exploded. 48 hours, 74 dead, parliament burned, massive economic damage.
A terrible cost.
Yeah.
But the key insight politically was the leaderlessness. Nepal's history was full of revolutions, 1951, 1990, the Maoists, where the revolutionary leaders just became the new corrupt establishment. A cycle of revolt and betrayal, as the source put it.
But this time, no single figurehead to co-opt or arrest.
Exactly. The lack of a leader broke the cycle. And this decentralized nature became really visible online during the chaos.
Oh, so?
As the state basically collapsed, protesters flocked to this Discord channel, Youths Against Corruption. It became this kind of impromptu public square, totally peer-to-peer, no hierarchies.
And they use that for political organizing.
More than organizing, they held what the sources called a Discord election. Described as this chaotic marathon session, like a Twitch stream, not a formal convention. Over 7,500 people voted right there on Discord.
And they actually nominated someone.
Yeah. They ended up nominating a respected former Chief Justice, Sushila Karki, as interim Prime Minister. It was like the internet spontaneously generating a political path forward when the old structures were gone.
An amazing example of decentralized agency bypassing the old system.
Truly incredible. But the challenge now, the sources stress, is for that generation to maintain that vigilance. To never again outsource hope, agency, or critical thinking to any self-proclaimed savior. Keep the power decentralized.
Which stands in really stark contrast to what we see happening in some established powers, like the U.S. example in the sources, the weaponization of captive audiences.
Yeah, talk about opposites. When Nepal saw power bubble up from below via Discord, this example shows the state using its own infrastructure for top-down political messaging. Specifically, the Department of Homeland Security Director, Kristi Noem, an unelected appointee.
Right, using TSA security checkpoints.
To broadcast political propaganda videos, blaming the opposition party for a government shutdown. To what the source called truly the most captive audience you can imagine.
I mean, you're stuck there. You have to go through security, you have to wait, and they're beaming political ads at you.
The source labels it a masterclass in propaganda. exploiting places where everyday people who might not follow politics closely are forced to be. Airports, VA hospitals, Social Security offices, using mandatory interactions with the state to push a partisan message.
And the source connected this to the broader Project 2025 playbook.
Yes, framing it as a strategy to leverage existing state machinery and unelected officials to reshape the political landscape, bypassing traditional media or political debate. It's a very direct form of centralized messaging.
So if the political sphere is this battleground, what about the digital platforms themselves?
Right.
The sources point to the decline of the hashtag as another form of centralizing control.
It's subtle, but really important for user agency online. We're seeing major platforms, TikTok limiting you to 5 hashtags, X, Twitter throttling them, Threads limiting to 1 topic tag, systematically dialing back the hashtag.
And their justification is?
Oh, it's all technical. Our algorithms, our NLP, our computer vision are so good now, we don't need users to manually tag things with hashtags. It's vestigial.
But the sources argue that's not the real story.
Not at all. The real story, the political truth, is that the hashtag was a tool created by users, for users. It allowed communities to self-organize, to classify information, to create shared meaning outside the platform's direct control. That idea of rhizomatic emergence.
Rhizomatic, like roots spreading out horizontally, spontaneously, not from a central point.
Exactly. Hashtags allowed topics and communities to emerge organically from the grassroots. By killing the hashtag, the platforms are taking that organizational power away from users and concentrating it themselves. They get to decide how topics are structured, who sees what. It's, as the author put it, learning to see like a state imposing order from the top down.
And it removes a layer of transparency and accountability too, right? That hashtag Black Lives Matter example.
Perfect example. When that hashtag was apparently being suppressed or glitched, users noticed because the hashtag was visible. It was a public focal point for demanding a fix. When the platform controls all the categorization behind the scenes, that public point of leverage disappears. It's a quiet theft of user agency.
Okay, this all brings us back to the human at the center of this amplification. If AI is automating skills, what's left? The sources make a strong case for good taste in software engineering.
Yeah, this is a really deep point. It's not just about being technically skilled, knowing the syntax, the algorithms. Technical skill comes from study, practice. Taste is different.
How is it defined here?
As the ability to adopt the set of engineering values that fit the current project. It's about choosing the right priorities for the situation.
Okay, give me an example, like the map filter versus for loops thing.
That's a great one. An engineer might love map filter, functional, readable, maybe less prone to certain errors. Another might prefer explicit for loops for raw speed, or because it fits the simpler philosophy of a language like Go.
Neither is inherently unskilled. They just value different things.
Exactly. And that's the core. Almost every engineering decision involves trade-offs between competing values. Speed often fights readability. Security can slow down development. A mature engineer with good taste understands this. They don't just have one hammer. They know which tool, which value to prioritize for this specific job.
Whereas an immature engineer might just stick to their favorite way regardless of context.
Right. They mistake their personal preference for a universal principle. Always use map filter. Or always optimize for speed. That's not taste, that's inflexibility.
So let's unpack the core engineering value set. What are these values engineers are constantly juggling?
There are quite a few. Resiliency. Can the system bounce back on its own? Speed. How close to the theoretical maximum performance are we? Readability. How easy is it for someone new to understand this code? Short functions, good names.
Okay. Then there's correctness. How rigorously tested is it? Using types, formal methods, flexibility. How easy is it to change or add features later without rewriting everything?
Don't forget scalability. Will it handle 10 times the traffic? 100 times? And crucially, development speed. How fast can we actually build and ship things?
So good taste is about knowing how to rank these for this project, this team, this moment.
Precisely. If you're building a critical financial system, correctness and resiliency might be top. If you're building a quick prototype, development speed and flexibility might win.
Which leads to the bad taste indicator,
Yeah.
inflexibility.
That's the key sign. Someone has bad taste if their preferred values just don't fit the project's actual needs. The source used that great analogy. They're like broken compasses. A broken compass might point north correctly if you happen to be standing right at the North Pole. But anywhere else, it leads you astray because it's stuck on one idea.
Like the engineer obsessing over 5 nines of reliability for an internal dashboard only 3 people use.
Exactly. They're applying a generally good value, reliability, completely out of context. They make the system super complex, hard for juniors to learn, slow to develop, all because they're inflexibly attached to reliability is paramount, ignoring the actual use case. They can't make the right trade-off.
So good taste is this elusive ability to be flexible, to choose the right values for right now, especially when AI tools might just optimize for one thing, like speed, by default. It requires experience, judgment, wisdom, really.
That's a good word for it. Wisdom and vigilance.
Okay, let's try and wrap this up. Synthesizing all these threads from the Pythoness Programmer sources, what's the core tension?
It really comes down to this. Technology, especially AI, is forcing the issue. We can't keep outsourcing our thinking, our vigilance, our agency. Whether you're a lawyer leaning too hard on AI, a coder navigating automation, or a citizen trying to be heard online.
The tech amplifies everything. Our best intentions, like using AI for exploration, but also our worst habits, like making excuses or falling for propaganda.
Exactly. The amplification effect means the stakes are higher. We have to stop sleepwalking through it.
We absolutely have to be hypervigilant. The sheer speed demands it. We can't afford inflexible judgments like those lawyers finding excuses. And we can't be passive about who controls our digital spaces or our political messaging. We need to own the mission.
The acceleration isn't stopping. The complexity isn't going away. The tools can help with the toil, but they also offer this really easy path to just not thinking critically.
Which brings us to our final thought for you, the listener. As AI gets better and better at automating skill writing the code, drafting the document may be the most valuable human trait. The hardest one to cultivate is actually taste.
That wisdom to make the right trade-offs, the judgment to know when the AI is helpful and when it's leading you astray, the vigilance to stay in control when the system just wants you to click, accept, and move on.
So the question for you is, how are you ensuring your judgment, your taste, keeps pace with the relentless acceleration of technology? Think about that. We'll see you next time on The Deep Dive.